which is the unit 10.3 282. Now this is a method that is new in this A-level course. It never used to be in there in the old spec. Okay. Now this method is a much cleverer method than the previous ones that you've seen on locating roots. Okay. So let's just quickly draw a diagram and see what this method is all about. So imagine you've got a graph that looks a little bit like this. Okay. And what you want to do is you want to find this root. Okay. So the method is essentially that you pick a point, and it has to be a sensible point, and we call that point, let's say, x0. And what we do is we substitute that into the function. Let's call our function fx. So this value is obviously going to give us fx0. Okay, so this height is then fx0. And if I was to then draw tangent line there, then what do you notice about my tangent line? My tangent line, where that crosses the x-axis, is getting so close to the root. Okay, and if I went one more step up and then drew a tangent from there, I would have a really good approximation of my root. Okay, so I've got x0, I substituted in the function, I get fx0, and then what I have is, then imagine if I had the equation of this tangent, at this point x0, then I would call this point x1. And if I then substitute that point x1 into my function f of x and then draw another tangent line, that would go very, very close to the root. Okay. Now let's see why this works. And actually we've got a formula. Let's write down the formula and then let's see where it comes from. So the Newton Raphson formula is xn plus 1 equals xn minus fxn divided by f dash xn. Okay, now let's just look at this triangle, and I'm going to enlarge it here. Okay, I'm just going to zoom into that for a sec. So this point is x0. This is our starting value. Okay, we always need a starting value for any iterative process. Okay, you've seen this in the previous two sections. This point we're calling x1. This height we have fx0. And what is this? What value is this? What relationship do we have if I wanted to divide x0 over the difference of x0 minus x1? This would get me the gradient, wouldn't it? The gradient at x0. Okay, we've got a relationship. We've got something that connects all these three values here. So if this is our formula, and now we're looking at where this formula comes from, let's just write down the gradient at x0. Okay, what would that be? Wouldn't I be able to find that if I was to differentiate the function f of x, and if I was to substitute x0 in there, I would get the gradient at x0. And I know the gradient is rise over, or difference of the y divided by difference of the x. Okay, And what I'm after is, if you look at the formula, and if this was x naught, I'm actually after x1, aren't I? So if I was to swap them around, I would get this. And if I was to swap again, I would, and if I wanted x1 on this side, then on the other side I would have x naught minus f x naught over f dash x naught. Okay, so this is exactly what the formula is, but it's written in a recurrence relation form. So it's xn plus 1 equals xn minus f xn over f dash xn. Okay, so this is where the formula comes from. Now, the key things to remember are that you can't just choose any starting point that you like. Okay, mostly it'll be given to you. But if it's not, you'll always have a way of figuring out what the best starting value should be. But if it's too far away from the root, you might never get close to the root and you might bypass it. Or if you ever have a stationary point, let's say that a function that we wanted to find the root of looked a bit like this, imagine. And if your starting value is at the stationary point, that's not going to work, because at the stationary point your gradient is going to be 0, and this formula it's not going to be valid. Okay, you won't be able to work that out. Graphically, if you were to use the stationary point as a starting value, what would happen is that the equation of that tangent line obviously it'll never cross the x-axis, so you'll never be able to get close to the root anyway, okay, using that. So that's why starting value at the stationary point is never going to work, okay.